Good morning, everyone. I'm going to wait here for a couple more minutes before we get started as we get people calling in. You'd think by the 5th webinar series I'd have music in the background and a movie to watch. Well, we're waiting here to get started, but you get just to look at me for 30 more seconds here. All right, I'll give it another 30 seconds and we'll get started. Thanks everyone for joining so far. All right, I got to keep talking, otherwise all you new people think your sound's not working. So, all right, let's get started. All right, good morning, ITS Heartland. For the last time this year, I get to welcome all of you back for week 5 of the 2020 ITS Heartland webinar series. My name still hasn't changed over the last 5 weeks. I am Kurt Rotering, and I am the current and past president of ITS Heartland and the traffic team leader at Olsson here in Kansas City. Also, still behind the scenes, doing an awesome job is our current president, Slade Ingstrom. He's a vice president of Transsystems out of Wichita. As always, if you missed one of our last week's sessions, the recordings have been posted to the ITS Heartland website. Just go to the annual meeting link on the website and a link to the recordings are down and on the left next to the week's date. This week is obviously being recorded as well, so should be up there later this week or first thing next week. As this is our last meeting in our 2020 webinar series, we have some special items on the agenda. We'll start with a quick update from Shailen Bhatt, our ITS America President and CEO. Then we'll have our vendor updates, some great presentations, and an Oklahoma State update. Then I hope all of you can please stick around after the state update to end with our 20th anniversary celebration. I have a number of PowerPoint slides that will provide some laughs and a trip down memory lane for a lot of you. So I'm excited to share that with you guys. Before we get started, I obviously want to thank our sponsors, which you see behind me. Their generous support has allowed us to provide these sessions to all of you for free. So thank you to HNTB, Transsystems, Walter P. Moore, ADCO, Street Smart, Snyder and Associates, Econolite, HDR, Olsson, SRF, JEO, Transcore, General Traffic Control, and Image Sensing Systems. Links to their websites are on the ITS Heartland website, so please go visit and see what products and services they have to offer. Again, thank you to our sponsors. I'm really excited that we were able to provide these 5 weeks of presentations to our membership for free, so thank you again. With that, please post any questions to the Q&A tab on the top right of your screen. And if the speaker is available, they'll answer them, or Slade and I will try to answer as we can, or we'll get back to you with an answer as soon as we can. So to get week number 5 of the 2020 ITS Heartland webinar series started, we have a vendor update. Up first is from Olsson, a vendor sponsor. Olsson is a full-service engineering firm with offices throughout the Midwest and is also a sponsor of the webinar series. Olsson serves the entire ITS Heartland region and can help with technology, traffic, and ITS solutions.
Olsson is a full-service civil design firm with services in engineering, environmental, field services, planning and design, and technology. We are a close-knit family of 1,300 employees spread throughout the Midwest, including many offices in the Heartland and around the country. Our experts are excellent resources for all things in transportation technology, from traditional ITS designs to TSMO and technology strategic planning, software services, and many unique, innovative solutions. We have significant experience with complex and innovative projects, including the planning, design, and implementation of citywide traffic signal systems, public and private communication systems, ITS systems, and software development for custom applications. We'd love to talk with you about traffic and transportation challenges you are facing. We are excited to brainstorm some innovative solutions with you.
Great. Next up is an update from Shailen Bhatt with ITS America. Shailen is the president and CEO of ITS America. Most of us know Shailen in some fashion or other, but here's a quick bio with a couple things that I did not know. Shailen graduated from Western Kentucky University. And that was one thing I did not know. He has been the executive director for the Colorado Department of Transportation, cabinet secretary for the Delaware Department of Transportation, and was a presidential appointee at the U.S. Department of Transportation. Shailen has been with ITS America for just over 3 years and lives in Washington, D.C. with his wife and 2 young daughters. Shailen, I'm excited to hear your updates.
Hello, and thank you for allowing me to speak today at your ITS Heartland meeting. I've been to a Zoom wedding this year. I've been to a Zoom funeral, and so I think it's only fitting that in this crazy year of 2020 that I'm bringing remarks to you via Zoom. And I would love to be with you. I'm not sure whether you would have been in Missouri or Iowa, Kansas, Nebraska, or Oklahoma. I do know I had a great time at the Cornhusker Marriott a couple of years ago, and it's just disappointing that we can't all gather again. But I'm convinced that we're going to get through this crazy period, and we'll get together again in person as transportation and safety professionals. And wow, what stories we'll have to share. So I actually the job I had before taking this job at ITS America was executive director of the Colorado Department of Transportation. Before that, I was the Secretary of Transportation in Delaware. And I would always say that, departments of transportation, and I think this extends to many of us who work in transportation, exist for 2 reasons, right? They exist to save lives and make people's lives better. And so, I've always believed that. I always believed that, whenever I was going into work, I was going in because I wanted to either, help reduce crashes or fatalities, or find a way to get somebody's commute shortened. And I think that expands to the broader ITS community. And so, at ITS America, we talk about our vision being, for a better future, one that is transformed by intelligent mobility, one that is safer, greener, and smarter. And so, I actually got started in transportation because when I was a kid growing up, there was a really bad car crash outside of my town. And in one car, there were like 5 teenagers from one high school. You can imagine in a small town, like what an impact 5 teenagers dying would have. But what actually got to me was in the other car was a couple. They were parents and they were on their way home to their family. And obviously they didn't get there. And I just remember being really scared as a kid that my parents could do something which was like really normal and common, which was like get in a car and leave and then just never come home. And so, in my journey as a DOT director, whenever I would get a, safety alert or a crash alert, and they would say it's a fatality, I would always go back to that. I was thinking, darn, we've not yet got to a point where we want to be, which is no fatalities on our roadways. And just from a safety perspective, I think that about 10 years ago, in 2009, I was a presidential appointee at US DOT, and we were cautiously optimistic because fatalities were down. Fatalities had come down, but then when we dug into the data, we figured out that, well, fatalities had come down because the Great Recession had happened, and when VMT went down, fatalities went down. And so we were very careful not to spike the football or to, feel like we had done very much, because nothing structurally changed. Only VMT had come down, and we were worried that when the economy started growing again and people started traveling again, that fatalities would go up, and we were right. So, you start to see from a base of like 30,000 in 2009, 2010, you start going up 31,000, 32,000, 33,000. But then something unexpected happened. VMT kind of leveled off, but fatalities kept going up. And, the year before I took over in Colorado in 2014, there were about 480 fatalities on Colorado roadways. When I left 3 years later, that number was over 700. And so, obviously it's been this massive increase. So many of us thought with COVID, maybe a silver lining might be that, traffic's going to come down and then hopefully fatalities will come down. Well, actually NHTSA recently released early fatality estimates, and the traffic fatality rate rose by 29% in the second quarter of 2020, even though overall road deaths were down roughly 2% in the first half compared to the same period last year. So we know that VMTs come down, but fatalities have gone up. And, it's like we almost can't catch a break on the roadway fatality pieces, where even now reducing VMT doesn't have an impact. And so it's incredibly important to focus on data and make data-driven decisions. But, everybody's very focused, as they should be right now, on the coronavirus and the safety impact of making sure that, 200,000 American deaths gets recognized for the tragedy that it is, and we prevent more from happening. But we can't get away from the fact that, for the last few years, it's been about 38,000 Americans a year are dying on American roadways. And so what we want to make sure that we continue on this piece. And I think we've engineered a lot of safety into our roadways. We have clear zones and speed limits and design standards. We've engineered a lot of safety into vehicles, airbags and crumple zones, and, now ADAS and, automated driver assistance system. But, one of the things that we're very focused on at ITS America is preserving the 5.9 safety spectrum. And look, we expect the FCC to likely take action on opening up the lower band to unlicensed devices later this year. But we do know that, there are deployments all around the country. And, whether it's, freight and platooning using the 5.9 spectrum, or deploying roadside units out there, or getting first responders to crash sites earlier. We know there are deployments all around the country. And so, we are hopeful as we continue this battle that we're able to preserve the spectrum, because, when you look at the data, we know that that major increase has come about because vulnerable users on the system, bicyclists, pedestrians, motorcyclists, they're dying in much greater numbers, which I think is consistent with the idea that distracted driving and driving under the influence has gone up the last few years. I used to travel around the country. In fact, I used to travel around the world. When I was at the Cornhusker Marriott, I actually left Lincoln and flew to Beijing. Not direct, apparently there are no direct flights from Lincoln to Beijing, but ended up going to Beijing. And, I don't do that anymore. I've gone from traveling around to walking up and down the stairs in my house. One of the benefits of not traveling is I got to teach my daughters how to ride their bikes this year. But I got to tell you, every time I'm out on the road with my 5-year-old or 7-year-old daughter, I'm worried, right? Is this car that's coming up behind me, does it see me? Does the driver, are they drowsy? Are they under the influence? Are they distracted? And I would feel a heck of a lot safer if, all of these vehicles and road users were connected, and we can do that with the 5.9. And so I think 7 months in, I think that we have figured out that technology is key to adapting to this COVID environment. Using Zoom, and other technologies to work remotely, but using contactless payment in transit, looking at our urban areas, what this means for freight and traffic management. I think we at ITS America believe that technology is our best tool in the toolbox to create that better future. And so from a safety perspective, we want to just continue pushing deployment because we know we can reduce fatalities that way. So I talked about going to Beijing. I was also in Shenzhen on that trip, and I got to see some of their electric buses. 2 years ago, we were all talking about the fact that China was deploying a fleet of electric vehicles the size of London's every month. And it was so many electric buses that they were actually going to reduce global oil demand in 2019. And so I think obviously from a global competitiveness standpoint, we want America to be a leader in battery technology and selling those new concepts and innovation that will allow the world to move forward. We had a great conversation with Chairman DeFazio the other day, Chairman of the House T&I Committee, and he talked about the bill that has passed the House, which puts a real emphasis on decarbonizing transportation. So a 500% increase in the all-electric bus program. I think just making sure that we are looking at things like electrification. So a lot of opportunity for generation in our right-of-ways for state DOTs and other agencies. So from electrification standpoint, what infrastructure do we need? How do we generate it and then get it there? And so look, we know that the transportation sector is responsible for about 28% of our greenhouse gas emissions, and regardless of the outcomes of elections and other things, we as a country have got to get our arms around this. And so California and Michigan have thrown down, I think, important gauntlets around getting us away from carbon fuels and moving more towards becoming carbon neutral. ITS America has long talked about how technology can improve safety. I think now we're also going to be focused on how we improve safety, but maybe from an air quality and pollution reduction standpoint. And again, I think that intelligent transportation plays a key role in that. If we don't have cars, sitting in traffic backups, which look, in Colorado, we had, even though outside the Denver metro area, going up in the mountains or when there were crashes on 2-lane roadways, we ended up with a lot of congestion. And so, it's not just an urban issue, it's also a rural issue, and we want to make sure that we're doing our part. And then, I think that we talk about smarter, and, one of the things that always stuck with me was the fact that Americans would spend about 100 hours, maybe it feels like 100 years sometimes, 100 hours a year sitting in traffic. And some of us are missing that commute now. Some of us are recognizing that it was terrible, but I don't think anybody is anxious to go back to just sitting in traffic. And so I think that whether it's mobility on demand, and particularly this idea of contactless payments and micromobility, I do remember in Lincoln, they were talking about microtransit deployments. And I think that is, a real focus as we move forward. So, we talk a lot about smarter, and, before it was about how to use sort of active traffic management. And that is still an incredibly important piece of this. But I also think that, we talk about data, big data, predictive analytics, machine learning, artificial intelligence. There are tools that are being developed now that we're just starting to scratch the surface on how we operate things much more efficiently. So, as an example, Iowa DOT is focusing on data flows from the digital infrastructure to create seamless flow of data, including data from connected vehicles and infrastructure, and working with DOT to focus specifically on data standards for work zones. Missouri DOT plans to implement a portfolio of integrated corridor management from autonomous and connected vehicles and smart infrastructure technologies. They'll also use the ATC-MTD funds, which, by the way, we need a new acronym. Hopefully that'll come out. But real-time operations, autonomous truck-mounted attenuator vehicles, or crash trucks, as we sometimes call them, and mobile edge computing systems, for supporting highway IoT applications. And we also need to be preparing for what I call the fourth dimension of traffic management, which is you know, air mobility, you know, delivery of passenger and freight by drone. I mean, these are things that, you know, sometimes we think of just as big city issues, but I think there are implications for right-of-way, air right-of-way, and how do you manage all of that traffic as we move forward. So, you know, I want to thank all of you for inviting me to speak today. I hope you have a wonderful conference. And, you know, I am, you know, I'm a naturally optimistic person. I think that, you know, we're going to get through this current health crisis, and whether it's next year at a Heartland event or in May at our ITS America annual meeting, which will be in Atlanta, Georgia, knock on wood, or, you know, for sure in 2022 in LA for the ITS World Congress. I think, you know, we're social creatures, we're gregarious creatures. We love to get together. We love to share stories, and I look forward to doing that with all of you at the next opportunity. Thank you so much and have a great conference.
Thanks, Shailen. Thanks for your thoughts and the update on what the focus at ITS America is for this year. Hopefully we can hear from you in person at our next meeting here in Overland Park next year. Next, we have a vendor update from Versilis Systems. Versilis is an industry leader in automated roadway access control. The company offers integrated access control solutions, which include a variety of ITS field devices, such as advanced warning signs and gates. Field devices are integrated using Versilis communication components specifically designed for the transportation industry to allow easy local and remote control. So, Versilis.
With more than 25 years of experience in highway safety, Versilis has developed various automated access control solutions that meet the highest industry standards. Road authorities across North America have adopted our solutions to increase the safety and efficiency of their traffic operations. Automated access control solutions include a number of devices, such as warning signs and highly visible gates, designed for all types of roadway facilities. All devices can be controlled and monitored locally and remotely. The Swift sign is an automated warning sign, only visible to motorists in its deployed position. Horizontal crash-tested swing gates are designed for access control on high-speed facilities. Versilis offers 3 horizontal crash-tested gate models, each horizontal gate having a different maximum gate arm length. For lower speed facility access control, vertical pivoting gates are generally used. Versilis offers 2 vertical gate models, each vertical gate having a different maximum gate arm length and operational speed. Whether permanent or temporary, access control solutions using our automated signs and gates are tailored to your needs. The solutions allow transportation agencies to increase the safety and efficiency of repetitive traffic operations, such as managed lanes access control and ramp closures. It also allows efficient maintenance and incident management, often critical for bridge or tunnel operators. All products can be controlled and monitored locally and/or remotely using a few simple components. Local control can be achieved wirelessly using the Versilis handheld remote control, or in a cabled scenario, using push buttons located in a nearby cabinet. Remote control can be done from a traffic management center using an NTCIP or a web-based interface. This remote control capability uses the Versilis commander interconnected with the local ITS infrastructure using Ethernet or a cellular wireless network. The Versilis control and monitoring solutions can easily integrate other ITS devices, such as lane control signs, flashing beacons, blankout signs, and traffic light controllers. With motorist and operator safety in mind, Versilis engineers bring experience and ingenuity to each project, from planning to installation, including testing to training. With Versilis technologies, you will achieve maximum traffic operation efficiency and reduced operational costs. But most importantly, you will increase the safety of highway workers and users. Please contact Versilis for more information about access control solutions.
Great, thank you, Versilis. I enjoyed the dramatic music. That woke me up a little bit more this morning. That was great. All right, our next presentation is from Jerry Roche with FHWA. Jerry is a transportation safety engineer at the Federal Highway Administration Office of Safety. Jerry has his bachelor's and master's from Iowa State University and has been with FHWA since he graduated. Jerry has been involved with ITS Heartland in the past, and I'm thankful he was able to provide a presentation on the safety performance of TSMO. Jerry, please take it away.
Hi, I'm Jerry Roche with the Federal Highway Administration. It's my pleasure to be part of this 2020 ITS Heartland Conference. And today I'm going to talk to you about the safety performance of TSMO, what we know and what we don't. So the information I'm going to share with you today comes from a recent publication called the Safety Analysis Needs Assessment for Transportation System Management and Operations, available on the link that you see there on the screen. This effort was funded by the Highway Safety Manual Implementation Pooled Fund Study. There's 22 states that participate in that, and they look to fund efforts to further implement the AASHTO Highway Safety Manual. To get started, I'll just start with a definition of what we mean by transportation systems management and operations. For MAP 21, it defined the TSMO as an integrated set of strategies to optimize the performance of existing infrastructure through the implementation of multimodal and intermodal cross-jurisdictional systems, services, and projects designed to preserve capacity and improve security, safety, and reliability of the transportation system. So, simply stated, what that really means is we're helping our state departments of transportation maximize the system that already exists. The days of adding a lot of mileage to our system or adding even more pavement or lanes to our system is quite limited. And so this is to help us maximize, to the extent we can, the existing right-of-way. And so there's a lot of different operational strategies that can help us do that. There's also safety impacts to those various strategies. In fact, one of the questions a lot of our safety offices, the state DOT safety offices will receive is, hey, we've been implementing this TSMO strategy and we're curious what the impacts have been in terms of safety performance. That's sort of an evaluation standpoint. Other agencies have also asked the question, hey, we're considering this TSMO strategy. What kind of impacts will we see on safety performance, both positive and negative safety performance impacts? And so looking more at a predictive side of things. And so, so far it's been very difficult for our state safety offices to really answer those kind of questions. And that's really what led to this project. So our objectives were to characterize the current safety performance analysis practice and the state of knowledge, as well as the skills relevant to TSMO strategies, and also identify gaps in their existing safety performance analysis approaches and come up with some research needs. So we went through the different safety performance approaches. We sort of used a hierarchy of different safety analyses. The first, of course, was analysis of crash data. That was sort of the primary method that was used or approach. In absence of that, we also had several surrogate measures of safety that were used, and even some instances of simulating crash occurrence and severity. So those will be noted in this report. Here you see kind of the organization of the report. I'm going to go through chapter by chapter to talk a little bit more in detail. So this was the framework that we used for organizing the TSMO strategies. This came from our FHWA Office of Operations, and we sort of look at management strategies sort of in three areas: incident and event management, traffic management, and then demand management. Following that, they also looked at tactical program areas, and then specific tactics or functions that fall into those. So just one example here so that I can zoom in a little bit for you. Under traffic management, we see active traffic management. We see a number of tactics here, things like ramp metering, implementing adaptive signal control, lane reversals, dynamic lane use, implementing temporary shoulder running, and even using variable speed limits. So those are all different tactics that are used, but those tactics show up in these three management strategies quite often. In fact, like variable speed limits shows up on this chart, or this table, if you will, 6 times. So it's a nice way to kind of show all these different things that are at play here. Now, chapter 2 is sort of what I consider maybe one of the bread and butter chapters. Chapter 2 looks at our specific safety needs and strategies that currently exist in sort of a synthesis of practice. So I want to say that we've got 15 different strategies you see here on the screen: managed lanes, part-time shoulder use, reversible lanes, dynamic lane use control, dynamic junction control, right metering, variable speed limit, traffic signal coordination, and adaptive signal control technology, transit signal priority, truck signal priority, queue jump lanes, various safety warning applications, work zone management, and traffic incident management. So 15 different strategies. In our guide, I think we've got about 92 pages that are dedicated to just looking at those existing state-of-the-practice research studies. And we were able to overturn or uncover a lot of different research analysis methods that I didn't know were out there, safety performance information. And so we've got that all synthesized now in one place, which I think is great. A lot of these were not necessarily your traditional safety analysis reports and whatnot. And so we were able to uncover a lot of information and put it in here as a synthesis, which I think will be very useful to our practitioners. I'll share just one example. This happens to be part-time shoulder use. If you're not familiar with part-time shoulder use, it uses the shoulder as an active travel lane when additional capacity is needed, and then it preserves that shoulder for other times, for refuge or recovery, when it's not needed for traffic purposes. Again, one of those things that a lot of agencies are looking at in the interim because they can't add additional lanes just due to the expense. So when we think about our safety analysis to actually analyze that, that can get very complicated very quickly. You need to look at which shoulder are we using? Is it the left or the right? What vehicles are allowed to use this shoulder? Is it just for buses? Is it HOV and toll lanes? Is it all vehicles? When does this part-time shoulder use operate? Is it static just during set times a day, or is it dynamic based on some sort of congestion threshold? Also, from a speed management standpoint, is the speed the same as the other lanes? Is it a posted speed? Is it reduced from the other travel lanes? Those types of things. Just some of the characteristics in there is also what does the rest of the geometrics look like when it's in use? So what's the remaining shoulder width? What's the lateral clearance to the roadside objects? What's the cross slope look like? Siping site distance when you've got curves, the design characteristics at entrance and exit ramps. There's also other spatial extents of a performance that get affected as well. On the facility level, things that might span multiple segments and multiple interchanges. If we add additional capacity, we might be attracting drivers from other parallel routes. And if we remove this bottleneck in this through this section, are we creating another bottleneck downstream? Now, for each strategy, you'll also see not only the several paragraphs explaining the study and what the findings were, but you also see that information in a table at the end, showing you all the different studies and, when possible, including the statistical significance or confidence intervals. There you see those. So just some of the common themes that you'll see throughout our strategies that we're dealing with. We've got TSMO characteristics such as, like I said, with part-time shoulder use, those are only operational during certain times of the day. Now, if you look at our typical safety analysis, we're typically looking at annual crashes. And so it's not very dynamic as far as looking at these daily, hourly variations. And so another example here, we're applying these TSMO strategies to help us with operational objectives. And so we've got things that operational performance metrics such as speed, flow, and capacity. On the safety analysis side of things, we're typically looking at annual average daily traffic for traffic volumes. And so things like speed, flow, and capacity, density really don't show up in our models very often. It's very infrequently that we talk about those kind of things. And so we've got some work to do in those areas. Another example in TSMO, a lot of these strategies like part-time shoulder use are used in relatively rare cases still. And so when we do safety analysis, we need a number of sites so that we have statistical significance, and that can be a challenge. Another challenge is that some of these strategies will influence travel behavior and within the corridor or the region across the system. And so drivers may change the time of their trips, the mode that they use, the route that they take, the destination, and even whether or not they even make the trip. And so that's very hard for us to capture in the safety analysis world if we're just looking at a specific location. So lots of opportunities, I think, and challenges as well. So chapters 3, 4, and 5 are cross-cutting syntheses. In chapter 3, we talk about the relationship between traffic operational performance and safety performance. Chapter 4 gets into the weather-related conditions on safety performance. And then chapter 5 tries to model some of the TSMO and travel behavior issues and interactions with safety. We'll talk just a little bit more in detail with those. So with the relationships between traffic operational performance and safety performance, we tried to note what is currently out there, some of those relationships that we know from research. There was quite a number of studies that we were able to find. This is just one example here, looking at different stations and locations from an incident. And so the colors represent speed differential, and so about a 7-mile-an-hour speed differential from posted speed. You see there that increases risk, particularly at station F. We've seen 0 and 5 minutes is the most risk for seeing a crash. And so that's covered more in detail there as well. So we also know there's an effect of weather and weather-related road conditions on our safety performance. And so we tried to quantify that and looking at all the existing research. This just shows a couple of examples where they've been able to make some adjustments for that, and then looking at crashes and safety performance. You see there, we've got a number or a plethora of information now with Orawiec sites, and so we're getting a lot of roadway weather data, but we haven't quite done as much trying to link that to safety performance. We've got to start, but I think there's still some great opportunities to do more as we start looking at these smaller intervals of time. And I mentioned that the travel behavior and safety interactions, again, we see a lot of changes, particularly when you look at the demand management strategies of route shift and temporal shifts and modal shifts. Very hard for us to capture that right now. So we've got some effects, and we've been able to do some modeling of those TSMO strategies, but it gets challenging because these are non-linear relationships between travel demand and TSMO. And so spillover effects are really hard for us to capture. Things like autonomous and connected vehicle technologies that are coming down the pike closer and closer. It's really hard for us to quantify that. And then really the need for additional empirical safety analyses and modeling. So a lot of opportunities there. It just shows one example here on this screen, looking at different strategies involving transit and HOVs that could affect safety performance and trying to quantify those. So. Chapter 6 gets into our safety performance analysis needs. We look at specific strategies, as you see here on the screen, and we also look at just the methodology needs or methodological needs. I mentioned the need to be able to conduct sub-annual safety data collection analysis to analyze safety performance effects beyond just one site, the need to analyze safety performance effects of traffic operational conditions, the need to relate study design and statistical analysis, and the need to explore mechanistic approaches to safety analysis in TSMO. So just some of the recommendations. This shows up in Chapter 7. We wanted to have regular dialogue between the three agencies, FHWA, AASHTO, and TRV, about safety performance evaluation needs. That is ongoing. We wanted to modify the CMF clearinghouse to have search algorithms that deal with TSMO, and that has been done. There's now 224 CMFs that relate to TSMO strategies that can be searched. We needed to have better coordination between the CMF clearinghouse as well as the ITS benefits database, and that has begun. We wanted to prepare some near-term research needs statements, and that has happened. I'm happy to report, and we'll talk more about that in a second here. And then also look at approaches to successful applications of short-term crash prediction. We were able to uncover 2 in that area. So just some ongoing studies of note as well. NCHRP has got a number of studies looking at safety performance of part-time shoulder use. We've got one that's looking at HOV and HOT lanes. Another one that's looking at dynamic lane use control. One for CMS for ITS applications. I think that's great potential there. New study that's begun that's looking at development of crash prediction models for short-term durations. That project has got some aspirations to look at 15-minute increments, and so we'll see where that goes. That research is just beginning now, but things you want to certainly keep an eye out for. Our Office of Safety Research and Development also has some projects looking at variable speed limits and adaptive signal control technologies, so those will be coming out in the next year or so. So it's great to see those things. Looking at some longer-term recommendations, they wanted us to talk about considering a TSMO-specific section to the CMF clearinghouse, Right now, our ratings are based on the crash reductions and the rigorousness of the safety analysis studies. And so it doesn't really get into the safety surrogate measures, and that's something we'll have to think about. There are some efforts, as I mentioned, 2248, but also another study, 1786, that's estimating the effectiveness of safety treatments in the absence of crash data. And so those are opportunities to see how we might be able to do that, and we'll be tracking those as we go forward. So, and then a longer term recommendation, looking at a strategic research program that could look at a TSMO tactical program areas. There's also suggestion that this could begin with a 1 or 2 day workshop involving maybe a TRB and whatnot, and so that's something that we're going to look at as we go along further as well. So I mentioned 2 noteworthy practices or approaches to safety analysis. One that was uncovered was on safety service patrols, and another was on traffic signal coordination. Those studies are available as well, or those approaches are documented and have application for other analysis of TSMO strategies as well. So we also have 3 research need statements that were developed. Those will also be pushed through AASHTO, I believe, for potential funding in the future. I mentioned those 2 approaches. There you see those, and certainly are available for download. And I want to thank you for your time. I also want to recognize RJ Porter from VHB for being the principal investigator on this research project. It was very interesting research, and we uncovered a lot more than I realized was out there. So thank you very much.
Thank you, Jerry. It's interesting to see how TSMO and the Highway Safety Manual are starting to come together, so thank you for that update. Our next vendor update is from HDR, a vendor sponsor as well. HDR specializes in engineering, architecture, environmental, and construction services, where they are most known for adding beauty and structure to communities through high-performance buildings and smart infrastructure. HDR provides much more than that. They create an unshakable foundation for progress because of their multidisciplinary teams that also include scientists, economists, builders, analysts, and artists. So HDR.
At HDR, we've always helped communities adapt to a changing world. From bringing power to the plains more than 100 years ago, to integrated tolling solutions, how we answer funding challenges to modernize mobility, and how we help our clients navigate the transportation technology landscape. With the unique perspective of many, we're motivated to shape our world for the better through collaboration and innovation. At HDR, we do things right to make great things possible.
All right, thank you, HDR. Our next presentation is from Gary Carlin, Director of Business Development for INRIX in the Southwest region of the United States. Gary graduated from Penn State University with a degree in civil engineering and has been in the engineering and transportation industry for the past 25 years. Gary has been with INRIX for over 6 years and is responsible for all public sector business development and smart city activities in the Western United States. So Gary, thanks for presenting.
Good morning and welcome to the ITS Heartland 2020 webinar series. My name is Gary Carlin and I'm the Director of Business Development for INRIX for the Southwest part of the United States. And I'm here today to talk to you about using big data to manage large incidents and focusing in particular on a PennDOT case study. But before we begin, a little word from my sponsor. INRIX is located at the nexus between the transformation of the automotive industry and the agency's use of big data. And by working with both of these parties, we're actually able to better serve both of them. By getting information and insights from the automotive industry, we can actually turn those around and provide those to the cities and vice versa. And it allows us to provide better information and allow our customers to make better decisions based on the data that we're collecting. But without further ado, let's jump in and talk about large incidents. So before we begin, I think I'd like to point out that incidents come in many shapes and causes and related factors. So a traffic incident may be work zone related, which as we know is accounts for a very substantial portion of all incidents in the United States. It could be an urban area or a rural area, which will affect how we can respond to it. It could have been caused by a weather-related incident, or our response to it could be impacted by that weather. And finally, there could also be some hazmat-related impacts. And I would submit to you that even even natural events in and of themselves could be classified as an incident. So snowstorms, last year Colorado saw some major snowstorms in the middle of the year. There were obviously bad wildfires in California this year. There's often, unfortunately, flooding in the southeast due to hurricanes. And we even have sandstorm-related road closures in the middle parts of the country, in particular Arizona, as a result of bad inclement weather. So how can big data be used to better manage these types of large incidents? Well, I think we're fortunate in that we already have, from Federal Highways and others, some really good research on the mechanics of how to deal with the incident themselves and how to clear it and things like that. But where big data can really come in and leverage all of that best practices is helping agencies find the incidents sooner and then communicate more effectively, not only with other agencies that will be involved in whether it's the cleanup or addressing the reopening of the roadway, and that could be obviously fire or police or EMS services or emergency management services, but also coordination with the public, with a goal towards helping them avoid the incident if at all possible. And if they're already in it, then actually helping manage the ongoing incident. And in this case, time literally is not only money, but it could also be lives. So the likelihood of a secondary crash increases by almost 3% for each minute that the primary incident continues to be a hazard. So the faster we can respond to these, the better for everyone concerned. So Pennsylvania, and PennDOT in particular, has been working on this for several years now and been working with INRIX as well. And back in 2017, they evaluated over 3,100 incidents that created what they referred to as a high congestion event. Now, what was interesting is, as part of their self-assessment, they determined that their traffic management centers spread throughout the state captured about 2/3 of the incidents. But 1/3, which occurred on the weekdays in the PM peak period between 1 and 4 p.m., were missed. And some of these were very substantial incidents. So as an example, shown in the lower right-hand corner, this is a congestion scan that was pulled out of the RIDIS analytics platform. The incident in question caused a 10-mile-long backup that lasted over 3 hours and was yet not detected by the TMC. So this is an example of where big data can hopefully help address finding the problem. And so what PennDOT decided to do was to create a new program to better utilize data to improve traffic incident management called EDC4. And they built it on top of all the stuff they already had in-house from the standpoint of crash records, roadway condition reporting system, Orawiec weather station data, and their maintenance database. To that, they add the Waze Connected Partner Program information, as well as the INRIX alerting that was coming in as part of our real-time feed that we're providing to them. And what they were able to determine was that between INRIX and Waze, they were able to detect almost 87% of all reportable crashes on the core roadway network, which is a substantial improvement just based on the previous assessment they had done. But not only that, and almost as important, is they found them much more quickly. So the INRIX incidents from our congestion alerts essentially detected the problem in about half the time as PennDOT's RCRS, and Waze was just behind at about 9 minutes. And so not only were they finding more, but they were finding them sooner. And this is crucial for being able to address incidents of all sizes. And as I think I mentioned, they took all this information and they put it into, ingested it into a Power BI tool set and created a dashboard. And this dashboard allows them to trace and track all of the incidents, all of the alerts by source, what roadway was impacted, the severity of it, the length of it, you name it. And by doing this, they can not only get a better handle on where everything is happening, but also on their reactions to these incidents and the performance management standpoint thereof. So back in 2017, they also focused on a work zone congestion-related crash study. And essentially what they were trying to do was figure out where in conjunction with a work zone were the incidents occurring. And what they found out was that 45% of all congestion-related crashes essentially on their core roadway network can be attributed to work zones. So this is a huge part of the overall problem. So the ability to better communicate issues around these is obviously critical. And what is shown at the bottom there is a graphic that PennDOT developed that shows the distribution by distance from the work zone of where the incidents occurred. And as you can see, a quarter of them occurred pretty far out, anywhere from 2 to 5 miles or longer. But still, about 66% happened within the last half mile, where essentially it looks like people maybe weren't paying attention and went through a dramatic reduction in speed. They also looked at secondary crashes. There were about 1,000 secondary crashes on the network in 2017. And the interesting thing to point out is similar to other studies that have been done by, as an example, Indiana DOT, most of the time there was a significant queue present for 15 minutes or longer after initial crash before the secondary crash happened. Now, this is well within our ability today to detect and disseminate information about those incidents. The other thing that was really fascinating and getting to the point of managing this is that 87% of the time they found that there was a permanent DMS sign within 5 miles upstream of the incident. And so they actually, if they had the ability, if they had gotten the information in a timely manner, they had the ability to communicate it in advance of the actual incident area. They also looked at some smart work zones with probe data. Essentially, the idea here now being that they are actually posting signs in advance of the work zone, in many cases a stepped traffic management area, and trying to see how that changed things from standard work zones. And what you'll see is there's a little bit different distribution from the first chart that they developed that I showed you 2 slides ago, where there's less occurring within the immediate half a mile, and there's a little bit more further out. And I think what this goes to is that people are actually now aware of what's going on, but may not be reacting in an appropriate manner to the information that they're getting. In addition to finding out about the incidents in a timely manner, which is the first step in being able to better manage them, PennDOT also decided to look at and ultimately procured the HELP program, or Highway Emergency Link Alerts platform, to actually manage incidents in real time. So this is, the incident's now occurred, whatever it is, and this is a tool set that allows you to better manage this in real time. And it's a joint offering from Information Logistics and INRIX. And so what is HELP? So the idea is that HELP is a wireless emergency alerting system that is based in the federal system, and it allows either one-way or two-way communication during closures or other emergencies. Some of the advantages to the system are no apps required, no pre-registration is required, and it allows officials, in this case DOTs, to very carefully define the geo area that they want to target the customers, in this case the driving public. So you can draw your geofence around a section of roadway and only impact or only message the folks that are inside that area. The initial message is sent via the iPause wireless emergency alerting system service, and it gives each of the drivers the ability and option to opt in to that particular event. And if they do, from then on, it's a straightforward SMS texting protocol, very low bandwidth and very lightweight, and it allows messaging in either one-way or two-way format. And where INRIX comes into this is our data is being fed real-time into the HELP system, and it allows the DOTs to see exactly where the congestion is, and therefore better define the geofence area that they want to communicate to. And this can be done in two ways or 2 steps. So you could draw one initial geofence around the actual incident, and then a secondary one that would be larger and outside this area that would actually allow them to then warn drivers coming into the area to divert around it. And I have examples of both of these I'll show you in a minute. So here's a case of the thing I was just talking about, the latter, which is you're trying to have the drivers avoid an area. This is one-way alert, so there was no option to opt into an event. And essentially, there was a major closure of 476 going into the turnpike, which was going to create potentially huge backups. And they were very worried about the spillover impacts. And so what they decided to do was to send out alerts 60 miles west and north on the turnpike to essentially divert this traffic. And the long and the short of it is it worked like a DMS for emergency purposes, and it really helped ameliorate impacts from that closure and gave drivers the opportunity to pick several different diversion routes in advance of getting to that point. Another example in this case with two-way communications. This is where unfortunately you already have an event that's ongoing, and you can see all the dots there are actual vehicles that opted into a help event, and WIA has been activated. And in this case, you now have the ability to communicate directly with all these folks, and they can send responses back, which you do not have to acknowledge or respond to, but it does give you insight into what's going on. It allows you to, if you would like to send messages directly to select groups, so for instance, just trucks, just school buses, things like that. And it will generate a SIP rep and after action report after the event is closed out. And just to give you an idea of what the usage actually looks like. So this is for about the last just under 4 years with PennDOT and the Turnpike. So there's been about 44 activations impacting over 12,000 different occupants. Well, that's actually drivers, so it could actually be a little bit more than that. And as you can see, they're spread out all over the state of Pennsylvania. And I know if you're not familiar with Pennsylvania, you're probably aware of Philadelphia on the east and Pittsburgh on the west, but much of the state in the middle is very rural, similar to much of the Heartland states. And so as you can see here, there's been a pretty good geographic distribution of these alerts on a wide variety of roadways. So I'm going to leave you with one last graphic here, which is information logistics today distribution of alerts by month of the year. And some things are interesting and some are kind of obvious. So if you've ever been in the Northeast during the wintertime, it's actually typically the worst in February and March, and that actually kind of is borne out by the alerts that are shown here. But it also shows you that there's surprisingly few alerts during the summertime when there's the high construction period, and there's 0 in September. But this again can also help go into an overall TIMS or performance management TSMO program and allow for better functionality and operations in the future. And with that, I'd like to thank you very much for your time today, and I'm going to close this out and open it up for any questions that you may have at this time. Thank you very much. Bye-bye.
All right. Well, thank you, Gary. Very interesting. One thing nice about having a virtual conference is you get presentations from all over the country, such as Gary's there. So thank you. Our next vendor showcase is from Street Smart Rental, who is another vendor sponsor. Street Smart is a nationwide full-service smart work zone integration provider. From system design to equipment rental, they have 21 years of experience helping DOTs, consultants, and traffic safety companies create safer, smarter highway work zones. All right, Street Smart Rental. All right, thank you, Street Smart Rental. Our last presentation is our Oklahoma State update from Marty Farris. Obviously the last of our 5 states, but probably not the least. I is ITS Heartland's Oklahoma State Director. He is the ITS Design Engineering Manager at Oklahoma Department of Transportation and has been with ODOT for about 8 years. Marty graduated from the University of Oklahoma with a bachelor's and master's in civil engineering. Marty has been a familiar face at ITS Heartland for a number of years. So Marty, I'm excited to hear what is new at ODOT.
Hello, and thank you for being here for the Oklahoma State Update. My name is Marty Farris. I am the ITS Design Engineering Manager for the Oklahoma Department of Transportation. Some might say we've saved the best for last. Others might say O just comes last in the alphabet, but we'll let you decide on that one. And so to get started, though, we're going to get into discussion of the Oklahoma Transportation Modernization kind of project that we're going through right now. This is an initiative of our Secretary of Transportation, Mr. Tim Gatz. It involves the three agencies that he oversees through the Transportation Cabinet, the Department of Transportation, the Turnpike Authority, and the Aeronautics Commission. So this year, 2020, they've been collecting a lot of feedback. They've got a consultant on board to help them kind of go through all of the data that they are collecting on the current operations of these three agencies and how they all work together, or for better terms, don't work together and should be. And so what they're going to do is take all this feedback that they're getting this year, and then next year in 2021, they're going to put together a plan for how to have all of these agencies, more efficiently work together. Be that just through work plans, or in some cases, certain levels of reorganization. So we really don't know exactly what our department's going to look like by the end of next year after some of these plans have been implemented. It might be small changes, it might be big changes. We don't know, but there is a little bit of that's going to be up in the air. But we're going to keep working through it and keep continuing to provide the best ITS solutions for the state of Oklahoma that we can. And we hope that some of this modernization effort will kind of help us to grow that partnership even further with the Turnpike Authority to make that even better. And as well as working within our own department with our field divisions and things. Hopefully, this effort will allow us to make better plans for the entire state. But so to go along with that, what we're going to talk about here first is our Turnpike partnership, kind of how it exists now. It's an informal partnership that's been pushed. It will be kind of codified, as that modernization process goes through. But for now, we spent the last year working really closely hand in hand, working on developing master plans for dynamic message signs, for cameras, working together on our fiber inventories, how to make those better and work together, the best. We're doing these for new and existing turnpikes. It is exciting that we do have brand new turnpikes in the Gilcrease and the Kickapoo, one in the Tulsa area and one in the Oklahoma City area, at least that are major, and then some other smaller little legs here and there. But these big new greenfield projects to really, make into good ITS corridors, to help put in the, layout where cameras need to be, where the DMSs need to be, make sure that everything is getting taken care of to help the motoring public as much as we can. So like I said, we are in the work together of laying out where all these locations can be, especially on those new turnpikes, but going back to all the existing turnpikes, with a focus first on the urban areas and then on the rural sections of the turnpikes, but laying out where we want dynamic message signs to help guide people around incidents that may occur, cameras to spot incidents that may occur, helping to say, all right, these are all the locations we want, so now we're going to prioritize them. How are we going to put them in? And the Turnpike Authority will, what's nice with working with them is that they actually have the budget to put some of these things in, unlike with some of our plans that we come up with for the department. But, that kind of goes hand in hand as showing if we can put together a big complete package and show it working even better for the Turnpike, then, hopefully that will help us out on the DOT side of things. And then that kind of leads into, the same thing for the DOT and our rural and interstate DMSs. I've talked about this before. Currently, we only have them at our ports of entry, basically where the interstates come into the state and go out of the state. We've got double-sided butterfly message signs at those locations for the three main interstates, and then as well as US 69 and US 75 down in southeast Oklahoma. But we're looking to expand and do projects on I-35 and I-40 to hit the midpoints and quarter points between Oklahoma City and the border on those roads. It is kind of unique in our geography that Oklahoma City is pretty darn close to being that the halfway point across our state for both interstates. It's just slightly off on both, but you can really take it as the midpoint for our state. But you might notice there for the I-35 project, it has design starts now. I am hoping to, by the time this presentation is over, that I will have the notice to proceed in my inbox that our consultant has been able to kick off on that design project. We've been waiting on it for a little bit, but it should be here this week. So fingers crossed that, by the time I'm done talking to you all, I'll have that email and we can get working on that. But yeah, we'd like to have that constructed by the middle of, started by the middle of next year. And then I-40, we really hope to follow that design project in right behind this I-35 project and just kind of keep that momentum going. So next, what we're going to talk about is some of the work zone things that we've got going on in the state for our ITS. We have implemented our first variable speed limit projects in the state. They are on work zones, so they're on the approaches to two different projects, one at I-44 and Airport Road, which is on the southwest side of Oklahoma City, and then a different one this is on I-40 over in the Midwest City area. And for those of you not from Oklahoma City, it's much like the United States in that the Midwest is just to the east of the I-35, or you would say like the Mississippi for the United States. But these two projects are our first attempts at variable speed limits. They're set up and they are currently just able to change the speed limit based on the conditions. They can have it set for daytime lower speed limits for workers present and things like that. And then we're hoping to get the the dynamicness of the automated being able to set speed limits based on the traffic levels here in the near future up and running. And then we're working on collecting our work zone limits. We currently don't have a great system for reporting just where the exact extents of our work zones end up for putting out on our different social media and website applications. So what we're going to try and do is do a better job of collecting the existing smart work zone data to get those extents from them. But then for jobs that don't have smart work zones, smaller jobs and things of that sort, we are working on developing a mobile app solution. And that's what these two pictures are here. It's just kind of a quick system here on the left where you've got, it just reads your GPS location, you tell it to start, and then you just kind of drive your job. And then at the end, you hit end. And then, it's tied to the job's construction number and you just put it in and we've got that construction zone to then start putting on our other mapping software. So talking about our maps that we have, one of the big things we've really been doing this year is an update to our website for our ATIS and our mobile app, which are Drive Oklahoma app. A really big push to bring them up to modern standards for both look and functionality. This here is a look at the old ATIS website, which is our oktraffic.org website. It's just very much a product of its time. It's been useful, it's functional, but it's just a little dated. You can see it's a little cluttered there with all the camera icons and the DMS icons. So that was one of the big things that we did in moving to the new system that you can see here. The ability as you get to different zoom levels for some of those clusters to come into single things. And then as you zoom in, they break apart into their individual cameras or DMS signs, just to keep some of that clutter off the map and open up visually. But the other changes here, I'm going to kind of show them from the mobile app side of things because they do apply to both, because one of the big things in updating both these systems was to make them look like a unified system. So now they will both be, the same look, the same style, rather than them being independent items. You really get that feel of, okay, these are both put out by the same entity. So here we'll start looking at the Drive Oklahoma app. There's just kind of a login screen to start up and a home screen. Most of the login will be for ODOT personnel to get into that later, and I'll kind of touch on that. But most people will just kind of start, especially in the beginning, start out as a guest. Then you'll get that home screen there on the right. But here's the new map. You can see it is very visually similar to what I was showing off for the new ATIS website. It's got the same clustering for the cameras and the DMSs. The big things that we've also added to both of these systems are the Waze integration. So we are pulling road closures, road incidents, road slowdowns, all of that information from Waze that will be being published to both of these devices. And then We've also started including our own weather system. Or we're pulling data from NOAA and other weather sites, but you can pull up the radar on top of our app to see, why possibly that the weather is in what's causing issues in the traffic being occurring. Just kind of show off, the new way is that the cameras will show up. You can pull them up, just in the app or on the map. While you're looking, you can kind of tour around, just pop up individual camera locations as you look around, and then they have the arrows on them to jump around to other cameras and other views. Or you can go into the specific camera area and get a bigger screen view, an easier way to navigate, along a single roadway or within an Oklahoma City or Tulsa metro area. The nice thing about that bigger screenshot there is that you can, slide your finger across that camera angle and you can turn to the different camera angles on the pole. So we've got on most of our poles 4 cameras that are combined, and so you can kind of get a 360-degree stitched together image just by swiping your finger around. It's really nice looking. Like I said, some of that we do have that login up front for our ODOT ITS personnel. What that'll allow us to do through the app is either the status of our field devices or control the DMSs. So what I'm showing here is the device status. We can see the last time many of the devices were updated, what percentage are online or offline for our DMSs, our cameras, and our DMS trailers. That's just a nice, easy thing to have in your hand, just to know, how things are going during an event, and being able to look at that. Or if we are out and about, to being able to put up messages on the DMSs while we're going around. A quick touch on just a few other projects we've got going on in the state. Our fiber network continues to expand on both the interstates and the turnpikes, especially on the new turnpike links. But even we're building out or working with partners to build out additional links along I-35 from Ardmore to Oklahoma City. Just some big long hauls just to help back up the existing system and give us more capacity moving forward. Snowplow tracking continues to grow. We're up to over 270 systems on our ODOT trucks. We have also 31 on OTA trucks now on Turnpike Authority. We had 2 or so testing with them before, but as we've kind of grown that partnership with them, we've put that up to most of a good chunk of their trucks. We've got 31, and that's all that they wanted for now. But I think the hope is eventually we will have a total of 530 between ODOT and OTA operational. And then kind of traffic incident management. COVID's kind of put a big dent in that for a lot of us, as certain facilities haven't allowed groups to gather and things of that sort. So we've been trying to work on developing remote and virtual instruction programs to go hand in hand with our TIMS website that we use for registration now. Ways that we can roll that out to keep, our roadway workers, up to date and current on their incident management protocols. So that way, we don't drop the ball there just because it's hard for us to meet in person. And then also our highway patrol has started a drone program for surveying accident sites to help clean those sites up quicker, for a quicker, surveillance and mapping for their reports. Get a drone out there and get the mapping done in 10 to 15 minutes instead of a couple hours for a major incident. It seems to be going well so far. They kind of got the drones up and running this summer, and they've started going on some sites, and we are working with them to be able to send the video from the drones back to us in our TOC, so that way we can have that live view of incidents that are going on as well. But again, I'd just like to say thank you for being here and listening to this My Oklahoma State update. It's been an interesting year for all of us, but thank you for coming out and listening to these ITS Heartland webinars. It means a lot for all of us to be able to share what's going on with each other and learn from each other.
All right, well, thank you, Marty. I appreciate you doing the update. Sounds like there's a lot going on in Oklahoma, so thank you for sharing all that information. Before we move into our 20th anniversary celebration, there is one housekeeping item I forgot to mention earlier, and that is a PDH form. So if you need PDHs or CEUs from this webinar series, we'll post a form on the ITS Heartland website for you to fill out which sessions you attended and watched. So please go to the website here in the near future. It's not up there yet, but we will put it up there. So now give me a second to queue up my slideshow. This is where it was nice that Slade had this all expertly done. And so you don't have to sit here and stare at me do this. And there we go. All right. Okay, so 20 years of ITS Heartland. First, I want to thank Matt Volz and Tom Hine for providing me all the information I'm showing in this slideshow. As you can see here from the list of past presidents over the last 21 years, Matt Volz was number 2 on the list and actually helped start ITS Heartland. So he is the keeper of all of the history, and he was on the board most of these 20 years until just the last few years. So thank you, Matt, for providing me all of this information that I will be sharing today. I just wanted to leave this up here so you guys can look at it. As you can see, we're on president number 20. If you look at the first year, Tom Ryan, he actually went 2 years, 2000 to 2002. So we are on year 20 or 21, but this would have been the 20th ITS Heartland annual meeting, would have been in 2020. So we'll still try to celebrate in 2021 in Overland Park a little bit. But in the meantime, let's look back over what I've dug up and what Matt shared with me. So first, this is this I think was the application, kind of an overview of ITS in the Heartland, the application to begin ITS Heartland as a chapter of ITS America. As you can see, we started with only 4 states: Missouri, Kansas, Nebraska, and Iowa. And I'll page through this. There's a lot of text on here, so don't expect you to read this, but I just found it interesting. I converted the whole booklet into the PowerPoint slides, so we're not going to read all of it. But as this mentions, this booklet highlights ITS programs and activities in the 4 states in the American's Heartland, and is intended to provide a better variety of the ITS programs and accomplishments throughout the Heartland. And there's our 4 states to start with. So a lot of fun old pictures here. Maybe you'll recognize some of these people, but I just want to highlight a couple of the interesting things I saw. So the Missouri section, what was going on 20 years ago, their Transportation Management Information Center was in the Discovery Center, a museum for children and their families. And obviously we all know what great facility Springfield has now for their TMC. So that's a fun little look. Also, Branson had this TRIP, Transportation Recreation Information Program, that they were just starting up. Basically, it was just detectors that automatically pushed things to DMS boards as people came into Branson. I tried to Google Branson TRIP, and it is definitely not called that anymore. And there's not much information after 2000 online for the Branson TRIP. St. Louis had an ITS system they were rolling out, partnership across Missouri. KC Scout was just getting going 20 years ago in 2000. So obviously that's been a huge success, and they've been a big part of ITS Heartland throughout the last 20 years. Kansas had their AVL system, tracking where all the troopers were. So that was new. Wichita was working on K-Log, and they have been for the last 20 years. Sorry, Slade, I'm picking on your city. The Turnpike looks like they started in the mid-90s, but it was highlighted in this brochure, and obviously that has recently converted to highway speed tolling, so that's been very nice. Nebraska's Motor Assist, which is still a constant at ITS Heartland. Still with Nebraska's Motorist Assist, and digital camera accident investigation, signal preemption, some fun old TVs and camera systems, information kiosks, Way in motion stations, variable message signs. I guess Iowa had a concept winter maintenance vehicle. And I know they've obviously progressed that here in the last 20 years. Iowa always is doing neat stuff with their winter operations. And we'll slowly go through this to enjoy the old time pictures. It doesn't feel like 2000 should be old time, but from these pictures, it sure looks that way. So that was the end of the brochure. As you notice, Oklahoma wasn't in there because they didn't join until later in ITS Heartland's life. And as you can see here this is actually the second volume of ITS Pulse that Matt shared with me. Oh, Matt. And as you can see, we're still only 4 states in 2002. Couple highlights through here as well. Gateway Guide in St. Louis becomes live in 2002. And then there's Matt. I had to highlight his picture. He was the president this time in 2002. So hey, Matt, it's a good looking photo there. I hope you're here today. Ah, he is. I just opened the Q&A section. So as he says, these things were state of the art back in 2000. So you're welcome for the photo. This one kind of made me chuckle. We had video conferencing was exciting. So we had to highlight that Nebraska has video conferencing in one of their conference rooms. Wichita had ramp metering projects back in 2002. They were coming out. Rural ITS transit was a big thing back in 2002. I highlighted this because obviously that's still a talking point and still something that people are trying to figure out how to do efficiently and best practice on rural transit. This one caught my eye too. In 2002, the Department of Roads, obviously now PennDOT, held an ITS conference that had 185 people attending. And there's a picture of it. And then I kind of went down a rabbit hole here and found that there was a link in this PDF to conference speakers and everything like that. I'm like, well, let's see if that link works. So I copied that link into the browser, and this is the web page I got. It was still active, but obviously not much here. These blanks in the middle are actually links, although the images aren't processing. So one was for a list of attendees, and that actually worked. And then the other one was for the program, and that link went back to some other Nebraska transportation site. But on the link of attendees from 2002 for this NDOR ITS conference, most of the people were from NDOR itself, with a few consultants and other cities mixed in. So it almost looked like all of Nebraska DOT or NDOR was attending this ITS conference. That's pretty cool that they were pushing ITS to their entire department, the entire organization at that point. We also did a survey back in 2002 from our ITS members. And the one thing I like to see was 82% of respondents said they were in favor of the vendor presentations, which is kind of neat because that's one of the, oh, sorry, Matt, popped up again. That's one of the highlights of our annual meetings every year since. We are very appreciative to our vendors and enjoy what they say, and it's always neat understanding with the new technology and things they have. So with that, I'd like to thank Matt again for providing me with most of this information. In the Q&A, he said that he did not give me this picture, so maybe that one came from Tom. So we'll just have this sit up here for a little bit longer. But with that, I hope you enjoyed that quick walk down memory lane with me. Obviously, I wasn't part of ITS Heartland 20 years ago, but hopefully we can revisit these slides or maybe more pictures in Overland Park next year as we're all together and get to laugh and joke and point and all that fun stuff. So with that, last thing, I want to hand it over to Slade, your current ITS Heartland president. He wanted to close this out. So Slade.
Thanks, Kurt. And really that's what I wanted to do with this, was thank you for not just being our pretty face that goes with these 5 past webinars, but also for all your leadership and commitment to the board. I know I speak for both the board and our membership in that we thank you for your leadership, especially through 2020. I don't think any of us will ever forget the 2020, and you get to be the face to go with that from the ITS Heartland side. So I guess we'll always remember that part as well. Speaking of 2020, I just want to put one more plug in there. We've said it at the end of each one of our meetings. 2021, we are planning in person, and as Kurt said, hopefully we're able to revive a little bit of this. And please mark your calendars, November 8th through 10th. We moved it back to the fall to give us a little bit better chance of making sure it is in person. So thank you all for attending, and I look forward to seeing everybody's smiling faces again next November, if not sooner. So thanks again, everybody.